Today we'll be looking at the inverse of a quadratic function. So first, just to review, an inverse operation is when an operation undoes another one. So if I start with, let's say, the number 8, and I want to do an operation such as multiplying it by 4, I will get the result of 32. So right now, 8 is my starting value, multiplying by 4 is my operation, and I get a result of 32. Now, if I start with that result of 32, the inverse of multiplying by 4 would be dividing by 4. And if you take a look, 32 divided by 4 is 8. So by doing the inverse operation, I've now undone what I did originally, and I have what I started with. Okay, so inverse operations or inverse functions will undo or reverse what was just done to it. Now, we haven't talked about what a function is really, so the function notation might be a little bit confusing for you, but remember that f of x really means what our y value is going to be at a certain value of x. So if I say f of 3, that will give me the y value when x equals 3. So we're going to know if two functions are inverses if we substitute in, if we say that x is equal to a. So that was like my number 8 in the original example. If I do that function for that value of a, and let's say I get a result b, if I now plug in that result into my inverse, so we have a -1 kind of like an exponent here for the inverse. So I do the inverse to my result of b, I would then get the original value of a that I started with. Now, we can also graph the inverse of a function by swapping the domain and range. And basically, any point x, y in the original function, by swapping the domain and range, each point will then become yx in the inverse. So now looking at a real example. So if I have a function f of x equals x plus 5 squared minus 3. Now I've already graphed it down here and labeled it, so you should know by now how to graph that using the vertex and the step pattern. So I've graphed that, and I also want to graph the inverse of that function as well. Now right now we don't know what the equation will be of the inverse, but what we can do, like was said on the previous slide, we can swap the domain and range. So if I start with this point right here, the coordinates of that point, it's 2 to the left, so -2, and then up 6, so the coordinates are -2 and 6. In the inverse, it will be those two numbers, the same two numbers, but swapped. So 6 and then -2. So I can now plot that point. So this point is the reflection or the inverse of that point right there. Doing this for another point, okay, so this point right here has 1, 2, 3 to the left, so coordinates of -3 and +1. So the inverse of that would be 1, -3, just swap them. So again, I can plot that 1 and then 1, 2, 3. And we got -3 right there. Now the rest of the points I'm going to pause the recording and quickly do. So let's do that. So on my left hand side I have all of the points on the original function, and on the right hand side I have swapped the domain and range, so I've swapped the x and y values, and I've plotted all of those points, and this is my inverse function right here. So it looks like a parabola, but it's sideways. Now one thing, when we have more than one graph on a single grid, it's very important to label each one with the equation so we know that which one is which. Now just for right now, we can't really call this a function. We'll be discussing that more in the next unit, but one thing you may remember, the vertical line test says that if you draw a vertical line and it passes through 2 points on a graph, then it's not actually a function. So we're going to have an equation for this eventually, but it's not a function right now. Now this says, does the inverse look like some kind of reflection? So you may take a look at this and say, okay, the parabola has been like rotated 90 degrees to the right and it's been shifted downwards. But try to look at it this way instead. If I draw this line right here, which would be the line y equals x, so meaning your y values are the same as your x values for the entire line, okay, each of these points is reflected on the other side. So you can take a look. So this point is a reflection of this point right here. They're equal distance from that line. This point and this point as well. This point and this point, and so on. They're all reflections on that line y equals x. Alright, so I'm sure you're all very concerned. So what do we label that second parabola as? We don't have an equation for that inverse. So now we're going to go over how to find the equation of the inverse. So I copied here, this is the equation of the original parabola that we started with. Now just remember that f of x is really your y value. So first thing I'm going to do is I'm going to just put y in the place of f of x. Now remember that for an inverse, whatever point you have, the coordinates being x and y, in the inverse they become y and x. You just swap them. So that's exactly what I'm going to do here. Instead of the y, I'm going to put x. And instead of x in the brackets here, I'm going to have y. Now there should be a square there, I forgot about that. Okay, so this is what we're going to start with for our inverse. I've just swapped the place of y and x. Except all the equations that we have in this course and in previous grades, we never want x isolated. We really want y to be isolated. So we have to do some work here. Now, if I want y isolated, what I should do first is, I don't want that minus 3 over there. So by adding 3 to both sides, and you don't have to quite show that to me. You can just put x plus 3 over here. Okay, so that moves the minus 3 over, so we're adding 3 on both sides. Now, if I want to isolate this y, I can't move the 5 over right now. I can't subtract 5 because this exponent has to be applied to it. So what I need to do at this point is I need to square root both sides, and that will cancel out the exponent of 2. Now, one thing, and I'm going to write it down here, if you square root a value, and we'll talk about this in class, you actually get a positive answer and a negative answer if you square root something. So again, we'll talk about that. And when you square root that, so you get y plus 5, at this point, now I can subtract 5 from both sides and I can isolate y. So the equation is root x plus 3, and that's positive or negative in front, and then minus 5. I was a little bit squished there. I was trying to keep my equal signs lined up, so I know next time I'll leave myself a little bit more space. But that right there is the equation of the inverse. So I can copy that over to my previous graph because I always want my graphs labeled. So there we go. Right there is the equation. So that's how we find the inverse, both by graphing and by the equation, and we'll discuss it a little bit more in class.